LCARA Ham Radio presents a Time Machine Tuesday vintage video release. Welcome to Lake Cumberland Amateur Radio Association. You can find us at LCARA.net, on Facebook, on YouTube, and on Instagram. If you're enjoying the videos we're producing here at LCARA, please help our club out by hitting that subscribe button. Also, give us some feedback on our videos. Click the like button, share with anybody who may find it interesting, and be sure and hit the bell icon to make sure you get notified of the next video release.
Okay, so on the Dipole antenna project, AC4DM and KY4CKP are taking our length of wire. Now, we've already cut this to 135 feet. So for your 80 meter dipole, what you're going to have to do, you need half a wave, and then the calculation is 468 divided by your frequency. If we do 3.6 for 80 meters, that comes out to about 135. So that's what we've got. Now we'll probably shorten it a smidgen as we go. And what we're doing is we're taking our 135 feet of wire here, and then we're going to double back and cut it in half, and that'll give us our two ends for the 80 meters. All right, so KY4CKP is now putting together the toroid for this project. I believe he's got that in his hand, and then he's got a length of the 174 cord that he's going to begin to wrap. Now, how many windings do we need on this, Chris?
I believe it's 14 or 15. Our directions tell us right here. So we will double check. See what we need.
And folks, we got these instructions right off the website, so this is going to be easy to find.
Let's see.
It's up at the top of that last page that you just went.
RG174.
12 to 14 turns.
Yeah, 12 to 14 turns for RG174. Only about 78 turns if you're going to use RG58 or something a little bit thicker and heavy duty like that.
We've got that really small diameter RG74, don't 174?
Yeah, RG174. If we're using RG, 300 or something like that,
right.
Similar to that. And they have also a pattern they recommend that you do. They have sort of a pattern. Of course, we're going to put a lot of turns on there, so it'll somewhat fill it up.
You turn something in one direction, you go across and back, turn it backwards the other way.
Yeah, turn it the other way.
That way, that has a tendency to cancel because of the polarity, And then all north this way, and then you turn it the other way, and it'll cancel out.
Okay, cool.
I have to cut it.
All right, so now what we've done is we've measured about 45 centimeters or about 17.7 inches as the length that we need to actually begin our windings around this toroid. And we're looking at about 12 to 14 turns, so half of them will go in one direction, and then we'll go across, and then we'll do half in the other direction according to our Elmer AC4DM.
Objective is to cancel out your stray RF. Let's get that on the outside of your line.
Okay. Chris, you got enough there, or are we going to have to lengthen it?
That's only about 5 on the reverse.
And you run out of wire?
Yeah.
All right, so we'll just have to do it again. Alrighty, so we're going to fish it through so that we can do the other 7 going in the opposite direction, and that'll cancel them out. So Chris just finished the last turn, I think. Now we go through the rabbit hole, up, around, and begin our next set of turns.
Come back the other way.
And again, once we get done, we'll bring you back. All right, so what we have is 7 windings on both halves, and then the 2 middle ones, which cancel. So the main thing here is to make sure you have even numbered turns on each halves, right, AC4DM?
That's correct.
All right, so that part of the toroid is done, and we'll bring you back in the next segment. Okay, so now what we've done is we've zip tied the toroid so that the windings don't come loose after we do the full install. So toroid is now done. Now we move on to the next segment. All right, so we're going in 8 millimeters. So what we're doing here, folks, is we're cutting the RJ174 to get the jacket and so forth. So you do this in 2 stages. This little cutter, we're going to put it in about 8 millimeters. We're going to
Okay, that's not quite right.
we're going to try that twist move that KY4CKP did again, and it should just go the depth that we need to remove the jacket. And yes, these cutters and crimpers are in the library of AC4DM. There we go. So now the outer sleeve or outer jacket has been removed. Now we move on to the next step. So what we've done here is we've laid out the SMA connector that we're going to use, and AC4DM is helping us out with the solder job. So we'll get right back as we begin the solder and the connector installation. All right, so what we've got is we've got the shielding back from it, and we've exposed the copper tip for ultimately the connector. So you can see this under the magnifying glass. This is pretty close to what we need. So now we get to put on our connector. All right, so take 2. We are putting some solder in the small little hole, which will ultimately anchor the tip that we're installing
And when you remove
onto
the soldering iron, it will wick down inside.
Right. And that's all you need, Chris. I think that's plenty. So if we've done our job, we got to let it cool. We have now a tip on the end, which will be a part of the SMA connector, and then we've got to install the rest of it. So we'll bring you back after this delicate solder job. Be right back. All right, so the final part to putting the connector together here is to take the shielding, right, Chris, and wrap it around the brass, and then put the barrel connector, or the barrel sleeve, I guess you'd call it, or just the crimp sleeve, and then crimp it down with the tool that you've got there in your hand. And we've already done that. So like Julia Childs, we're showing you the finished product here. But Chris yanked on it pretty good. Didn't come off. So we think we've got good solder, and we think we've got a good crimp. And we'll bring you back in the next segment for our next phase. All right, so Don is taking off the outer jacket here on the 174 on the other end, which ultimately is going to be the shielding as well as the center conductor. One of the dipoles will solder to just the shielding, and one of the dipole ends will be soldered to the center conductor. So again, Don's using his super sensitive shield removal tool. Just about got it. Or you could use one of those, yeah. All right, so we're bringing in the actual tool here for removing the outside shielding on the 174. Boom.
There it is.
And there it is. All right, so we'll pull the shielding back, expose the center conductor, and then we will be soldering the 2 dipole ends, one to shield and one to center conductor. We'll bring you right back. So now the, I guess you call it the finished product of exposing the center conductor with the shielding is now done. If I can get this to focus, there we go. The shielding and the center conductor are exposed, and those 2 parts will be, thanks Chris, those 2 parts will be soldered, one to one dipole half and the other to the other dipole half. So when we come back to solder, we'll bring you back. All right, so now we're tinning the shield wires and the center conductor. KY4CKP's already applied some flux to the wires. Yeah. Waiting for it to heat up.
Put the solder against the tip of your iron where the heat is. There you go.
All right, now we're moving to the center conductor. Just doing the same thing, just to make sure we get good connectivity when you're using these braids. A lot of this wire is just a copper braid. That looks good, Chris. All right, let's zoom in a little bit here.
And we'll trim that down.
Nice. And then we're going to trim both of these down. So we'll be back when we're ready to solder the pieces together. Okay, so now we're soldering the two together. This is one of the dipole ends to the center conductor, and we're just now basically making them electrically connected. And then we'll trim this off to make it pretty. Alrighty, so we've got one of the dipoles now soldered to the shielding of the RJ174, and we've got the other dipole now soldered to the center conductor, and we've got them neatly moved to either side. We're going to put some goop, I think is the technical term we're going to use, some kind of glue or something, but just to make it a little bit more permanent, and then this part will be done. And we're really close at this point. We've got an end on the other end of the 174, and now we've got the two dipoles connected. Won't be long before we'll be testing SWR. Be right back. All right, we're back. We're about to do some hot glue utilizing the Cricut glue gun here provided by WM4LM. And if I can get this to get a little bit closer. Oh, that's looking beautiful, Chris. It's almost like you've used one of these before. But we got the pink glue gun, and yeah, we're going to call it the Cricut. Some of you will get that reference. And we're just going to do a nice little messy job here, but good enough. We just wanted to protect it and to keep the wires from moving around. And we're done. We're going to let this dry, and then we will bring you back. All right, Chris, this is our first test of the new non-linked dipole at the moment. We've got our ends soldered together. We've got our wires soldered together. We put a PL259 here on the end so that we can connect it to the MFJ 259 that AC4DM is going to loan us, and we got to string this up. So we'll bring you back after we get it strung out and we have it connected to the meter. Now we're out here, we're going to be hooking up the MFJ 259 to the newly constructed antenna. We're hoping all the connectors are good and that we'll get a good reading. So let's see, we're going to hook it up to the battery here to give it a little bit of power. And let me switch over here and look over his shoulder. There we go. 3.6.
2.058 there, says 3 to 1, so of course it's laying on the ground,
Right.
so it's not shorted or anything of that nature. So
That's good. That means we're in the ballpark.
yep.
We are in the ballpark. So your megahertz is there on the right. We're at about, what, 3.3? And the...
well, it's actually 2 down to 2.05 down because it's extra long.
oh, okay. And the SWR is
It's 3.3.
3.3. Yeah,
Yeah.
okay. Yeah, that's the way mine is on the... And if we go all the way up to 3.6, what is it?
Let's see if we can. Oh, it ain't getting it to us. So let's see, we want
You want to be between 2147 there. There you go.
right there.
And then dial it clockwise to 36.
Yeah.
There we go. Too high.
Yeah, it's still up high. Possibly if we'll get them off the ground, it'll make a difference.
Well, what we can do is Chris and I can pull them up off the ground and see what you get.
Okay, well.
All right, let's give that a shot. Chris, it looks like, let me stand next to Don here. It looks like, we're going to get you on camera today, Don, that we were at 1.6 at 3.168 megahertz.
Right.
So we're below the band, which is what we anticipated. But that we got it down to that on the first try after all the soldering, the connector creation, all of that. We're right where we thought we would be, and now we just need to tune it by adjusting our length, right?
Just shortening of the length will bring it up in frequency.
Bring it up in frequency. So, folks, we're not done. We're going to do a little bit of tuning. We want to get the 80 meters part of this tuned, and then we will bring you back, and we'll see what the MFJ analyzer shows us once we shorten it a little bit. But now we got to make some calculations. How much shorter do we make it? So, Don, what would you typically do? Take off a few inches at a time, or how do you?
Well, no, I'd go something like 2 or 3 foot and start there and see what that does. What are you fellas doing over here?
Gentlemen, so now after a couple of tuning exercises, what was the SWR again there, AC4DM?
Well, at about 3.6.5, it was 1.5 to 1.
1.5, yeah, 3.6, actually it was 3.7, wasn't it? 3.7 point something, it was 1.5, so that gets us up on the band a little bit.
Yeah.
So our next step is now to figure out our 10 meters,
Right,
20 meters, and 40 meter lengths.
right. You need to take your formula and figure out your 10 meter lengths, cut them to that, and then tune that to the frequency that you want to tune it for 10 meters. And that's where you want to set it. And then you work outward from that point.
Okay, all right, gentlemen. Folks, we'll bring you back once we start figuring out the individual links. We'll probably do the links on one end, kind of show you what we have done, because at this point it's just segmenting this wires, the 2 dipole wires, and then tuning it in. So we'll bring you back in the next segment once we begin the links. All right, we're finishing up this afternoon on part 1 of our linked dipole series. AC4DM, what were the final numbers for 10 meters? Now, this is our first link, and it took several iterations, but what did we eventually actually see?
Well, what we actually seen was that the low SWR was like 1.1 down at about 28,200, and all the way up to 28.8 is 1.5, so that covers the band, that portion of the band with no problem.
That's really usable.
Really usable.
Chris, what did we learn on this particular project?
Well, you have to have a consistent testing platform. So you need to make sure that you're set up how you're going to deploy, and that way you'll get legitimate numbers on SWR and your impedance and everything else.
Right, because I mean, we're not trying to hide anything from anybody. We probably spent the last 2 hours just making sure that we had the right length and that our testing platform was going to match how it was going to be deployed ultimately. And once we had all those things, then we really started to dial it in a lot quicker. And just to show everybody, you can see we're utilizing this telescoping fiberglass pole to get it up to about 21 feet, which is what is recommended for the soda beams that we're trying to mimic here. And I think it turned out pretty well. Again, this is just the first segment, which is for 10 meters, but we're looking to also do 20, 40, and 80, right?
Yeah, I think those are going to be 4 good usable bands that a lot of hams would use for any kind of deployments, whether you're doing soda or PODA or any kind of work.
Exactly. Well, alrighty, we'll cut it short here. For the Lake Cumberland Amateur Radio Association, I'm KY4 BDP Brian.
I'm KY4CKP Chris.
I'm AC4DM, Don.
All righty, gentlemen, we'll cut it here, and we'll see you guys in part 2 when we add the other segments. 73s.